Hey Austin, it's Mark. Just apologize for not getting this file to you on Friday. Things got a little bit crazy, but basically this is kind of this is actually going to be a composite boat, but I'll just show you how the software works. Um, our toolbar is over here, and I guess I can move it anywhere, but I'll just use it here. So first I'm going to create the pieces. So I select the pieces that I want created, and then I just hit create piece, and then I'll go and select these pieces down here, and again hit create piece, and then there's a stringer down the middle, which you can't really see, but it's this little gap in here, so I don't need to do anything there, but just wanted to make you aware of that. So basically I have my sides or bottoms selected in two pieces. I just go click this button here, and now you can see that the two pieces are here on the bottom. The next thing I want to do is go into convert to an exact flat part, and what that does is take my SolidWorks part that I've selected, and it's going to bring it into exact flat, and that's where the flattening takes place. So goes through here, takes those two pieces. Now it's going to come up with this, which is material database. So our software works on a material database. The material database stores all the information on different materials. In this case, I'll make a carbon fiber part out of these two pieces. So I select carbon fiber. It's a 2x2 twill, 50 inches wide, and it has the different information based on what the fiber materials composed of. It's now I've got that. I've applied a fiber, composite fiber to this part, so it's gone from a silver to a black. And the next thing I'm going to do is basically go into my flattener, open up my flattener window, and you can see all these triangles in here is kind of crazy. So what I'm going to do is I'm going to what we call adaptively remesh. So these are all exact flat tools. So I'm going to simplify this mesh. Basically, that's what adaptively remesh. And if you look at it when I do it, you'll see what I'm talking about. So I'll just hit this A, and wow, voila! It's basically taken that very congested triangle mesh and created a very uniform um, shape. Once I've done that, I'll hit my optimize button, and it's going to flatten based on the parameters, which is the material that I selected, which was this composite twill. So now I have my 3D part over here. I have my 2D flat pieces over there. I'm just going to hit OK, and I'm going to bring that into the next part, which is uh, basically my pattern view. So it's going to go take those pieces and as flat pieces, bring them into the next window, and I'll just click on my pattern view, and there's the two flat pieces. So these are the flattened pieces that would go to a cutting machine, or if it was for metal, it would go into a CNC cutter or a laser cutter. So basically that's flattening the boat hull. The next thing I want to do is flatten the shoe. So I'll go in and I'll open the shoe file up. I think it's SolidWorks part. Okay, so let's go find the shoe. Upper shoe. So this is from a laser scan, and it's a little bit different. It's quite a bit different, actually. Um, as I mentioned to you before, I'm not like a SolidWorks guru. I know how our software works. I don't really know functionality in SolidWorks that great, but what I'll do is go through the same process. I create the piece, and how I do that is just basically, this shoe is actually made up of 23 separate pieces. So if I didn't want to, if I wanted to select all the pieces because they say they were single pieces, I could just hit create all, and it's going to go through, and you can see it's populated 1 through 23. So there's 23 pieces here. Just hit the check button here, go into convert to exact flat, and this will take a few seconds because it's going to go through each one of those pieces and, you know, say, okay, this is piece 1, this is piece 2, and of course because it's a laser scan, it's going to say that that's pretty large. Oh yeah, we're up to 11, 12, 13, 14. Okay, so 23 of 23 is done. Now it's updating the flat pattern. So when I select the pieces, it's not only just selecting those pieces, it's actually pre-flattening each piece. So it takes a little bit of time. Our flattener is a two-stage flattener. It creates a box flatten, and then when you select the pieces you want flattened. So it's actually doing something while we're waiting. And then the final thing is optimizing that pattern. So 7 of 23, 8 of 23. I have another shoe model, but it's at my office. I'm actually doing this video Sunday afternoon at my house. So I'm using my laptop and see how this goes. So basically we're there. Same thing, ask me what kind of material are you going to use. Let's say it was a leather shoe, and leather is red. Whoops. Okay, here we go. That's weird. So go into our flattener, and you can actually see the stress map that we apply to the shoe. So there's the shoe over here, all 23 pieces of it. Now the next thing I want to do is I'll just go and do they call a quick adaptive remesh of the shoe, which we did with the boat haul. And then so we also run an FEA, and finite element analysis on the shoe shows that on the 3D part, these two pieces up here are heavily stressed, right? Red is 20% stress, and that orange color is about 15 to 18% stress. And that's why you want to optimize it. So once we optimize it, you'll see these colors actually start changing. See? And it's going through pretty quick. There's two pieces here that I know because I did it before that there's a little bit of an issue. But this thing's just banging through it pretty quick. Okay, wow, we're done. I'm impressed. I'm going to hit OK here. And once I hit OK, it's going to rebuild all those pieces. And then we go to our flattening window. I'll hit OK when it's done. So, yeah, I'm pretty impressed for the amount of the scan, going from a scan and then remeshing it, and then actually it's really quick. So there we go, it's updating the model. And just about done. No, just to let you know, I did this model earlier today, and since there's a hide command in SolidWorks, and when I go into my pattern view, and maybe you can send me an email on what button I need to turn off, but when I go into my pattern view, I'm going to have the shoe is actually there, and I don't want it there. But I think with laser scans, sometimes it shows up in my pattern view. These are all my, by the way, these are all my flat pieces here. And I'll show you one thing on the shoe. Uh, anyway, so if you know how to get the shoe out of here, let me know. I think it's like view and there's display and you turn something off, but I don't know which one you turn off. Anyway, let's just take a look at this piece of the shoe here. I'm gonna add a seam, and the seam is just basically where you stitch the thing together. So let's say I'm gonna put a seam here along this edge, and what I'll do is as I put the seam on this edge, you'll notice over here on this edge another seam shows up. So we track all the edges on the parts, and so on our 2D pieces, when we create a seam on one piece, it automatically projects that seam onto the piece that it gets sewn to. And this is really important because I don't think there's anybody else that actually does it automatically. I think there's other products out there that are actually more expensive, but they don't do the automatic seam matching. And the other thing that we do is if I go down, this is really important for like soft goods when you're sewing stuff together, is we have these things called notches. And notches just allow the sewers to know where the pieces get sewn. And in this case, what I have is a 1/4 inch V notch. So I can create a notching chain, which will say, take a V notch and put 3 V notches on that. And you, just as I said that, you could see those 3 showed up. So these notches here would line up. These are what you use to align your pieces for sewing. I'll just hit the green checkbox again. That's a SolidWorks command. And you can see here's my 3 V notches. Here's my 3 V notches over here. So the sewer knows this gets sewn to this. That's basically how the software works. Once you have your pattern done and you've added your seams and add your notches, you would just simply go out to your marker. And a marker is just it's a term that's used by cutting table people. The marker is just how the pieces lay on the cutting table for cutting, or if it was a plasma cutter for that boat hull on the plasma cutting machine. And you can just see that like it just lays everything out on the table. Up here it gives you a total cost. So the total cost to do one shoe is $1.70 in that leather material that I'm using. And there's all my markers there. We also have automatic nesting. Unfortunately, I don't have a nesting dongle here at my house, but if I did, I would just hit nest. It would automatically nest all these pieces, so it would optimize the material count. One thing you can look at is if I move pieces up here, I can actually manually move them. And people that have like really big parts, like the boat companies and whatnot, they might not nest the pieces. The exception would be for the people that are doing metal boat hulls. They actually want nesting, and we have built-in nesting. So you don't need to have Sigma Nest. You can use our nester, and it totally ties in with SolidWorks and our Exact Flat. So that's basically everything in a nutshell. I'm going to send this off to you, and I'll try to send out some more information on testimonials we have for the shoe companies, and hopefully we can talk again on Monday or Tuesday, Austin, and get in front of your customer. All right, have a great rest of the weekend.